Hello guys, it's Lemniscate here, and today we're gonna solve some proof questions. Okay, so number one, prove that for any integer x, that x times x plus 1 is even. Okay, seems easy. Let's do it. Wait, how do I do this? Okay, yeah. I'll just put this here. Yeah. Wait, guys, give me some time. So, proof for that any integer x. Let's say, if we say any integer x, x will be either 2k or 2k plus 1, because any integer can be divided into odd and even numbers, right? It's one of these two, so we can divide into two situations. And now we just, let's say x was 2k, then if we substitute x for 2k, then it becomes 2k plus 2k multiplied by 2k plus 1, which would be 4k squared plus 2k. And now if we group it by 2, it becomes 2k squared plus, oh wait, pardon me, 2k squared plus 1. Okay, and now we know that this is even because of the 2. And this will always be an integer, right? Because k is an integer. I should have probably stated here, but k, it says k is integer. This is a condition we're given. Well, I gave. And now since k is an integer, this number will always be an integer no matter what. And now 2 will make it even. So, this will always be even. Now let's say x was 2k plus 1. Then if we substitute 2k plus 1 to x, then it'd be 2k plus 1 times 2k plus 2, which would be 4k squared plus 4k plus 6k plus 2. And now if we group it, it becomes 2k squared plus 3k plus 1. And this will obviously be an integer because we stated here that k is an integer. Because for this to be odd and this to be even integers, k has to be an integer. So now that we know this is an integer, when we multiply it by 2, this will always be even. So now we proved number 1, which asked us, prove that for any integer x, that x plus 1 times x is even. And now let's solve b. Prove for any odd integer that x, there existed integer y, so that x squared equals 8y plus 3. Okay, so let's say it said any odd integer, so let's say x was 2k plus 1, where k is integer. K is an integer, right? So now you just put it in. 2k plus 1 squared equals 8y plus 1. I just substituted x, 2k plus 1 for x. So this will be 4k squared plus 4k plus 1 equals 8y plus 1. Now we take out the 1s and divide it by 4. K squared plus k equals 2y. And now we can group it like this. k times k plus 1 will equals 2y, where y is integer. And now we can say k is an integer, right? Any integer. So k can be, it's basically number a, but repeating. Let's say k is 2m. This is the first situation. Then 2m multiplied 2m plus 1 will equal 4m. Well, it's gonna equal 2m squared plus m. Because I just took the m out and then multiplied the m, but not the 2. Which will equal 2y. So, and since m is an integer, though integer y does exist. Let's say k was 2m plus 1. Again, where m is an integer. So, oh, sorry guys, I was too focused. So basically what happened was 2m multiplied by 2m plus 1 is equal to 2 multiplied by 2m squared plus m, which will equal to 2y. So I just crossed out the 2, and the integer y does exist. I just proved that. So now let's prove it when k is equal to 2m plus 1, where m is an integer. So we just substitute it again. So 2m plus 2 multiplied by 2m plus 1. Then we take out the 2 and m plus 1, m 2m plus 1. And now we have that equals to y. So y will equal to m plus 1 times 2m plus 1, which will be an integer because m is an integer. So now we just proved number B, and if you guys have any questions about this question, then you can comment in the below comment section or ask me by email, okay? Okay, like, comment, and subscribe, and be a tryhard like you always have been. Wait, what?